Okay, in the double angle formula, we have three kinds of double angles, so sine double angle, cosine, and tangent. I'm going to show you how they are kind of came about. Okay, first one, sine 2x. Of course, you already have this,
Strategy video.
Oh, right. Okay, let's finish this first, and then if we have time, we can do the strategy video. Okay, so sine 2x. Sine 2x is the same. Let's think about 2x. What is 2x? It's what plus what? X plus x. So we can think of this as sine of x plus x. Okay, now sine x plus x, we can use our sum and difference identity, right? Okay, so what is the sum and difference identity for sine? You have to go right now. Sine, cosine, cosine, sine. Okay, so this becomes sine, cosine, plus cosine, sine. And they are all x's, so it's kind of easy to do. All right, now sine, cosine, cosine, sine, and they're both x's. So can we simplify this further? Yes, so this becomes what? 2 sine cosine. Okay, and that is the identity. So this is what you need to memorize. Now, if you forget the identity, you can always start from the sum and difference formula. All right, so.
How did you get 2 sine cosine?
Huh? Sine, cosine, and then cosine, sine. If you just changed it around, it's sine, cosine again. So there are two of them. So it's 2 sine, cosine. Okay, so I'm going to erase all that and then put it here. 2 sine, cosine. Okay, so that's the first identity. Second one, cosine 2x. We can try the same thing, but I don't know if you really want to. Cosine 2x is cosine square x minus sine square x. Of course, you can do cosine, cosine, sine, 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 and get there as well. You can try it for yourself. Now, cosine 2x has 3 versions. This is the first one, cosine squared minus sine squared. The second one is very easy. We just need to change sine squared. Sine squared is also the same as what? 1 minus cosine squared. So we can think of this as cosine squared x minus 1 minus cosine squared. Okay, now we can just distribute a negative sign, and that will become cosine squared x minus 1 plus cosine squared x. So what does that simplify to? 2 cosine squared x minus 1. Yeah. Oh, you want to sit there? Okay. So that is our second version of the identity. Okay, this is the second version. So I'm going to erase this again. This is the second one you have to memorize. 2 cosine squared x minus 1. All right. Do you guys think you can get to the third one yourself?
No.
I think so. You're going to change cosine squared. Okay, change cosine squared into something with a sine. 1 minus sine squared. Okay, and then try to get to your third one.
1 minus 2 sine squared.
Good, but let other people figure that out. Hmm? You already did that? Okay. We're changing this into 1 minus sine squared. And then simplifying. Okay, so change that cosine squared into 1 minus sine squared and then simplify. Okay, you should get 1 minus 2 sine squared, right? Okay, so those are the three versions of cosine 2x. How do you know which one you want to use? You don't, you just use one, and then they all get you the same answer. When you do proofs, maybe one of them is a little easier than the other one, so you kind of guess and check. All right, the last one, tangent. Tangent is always the same as what? Sine over cosine. So you can always do that, sine over cosine. Of course, it also has its own formula. And I don't really remember that one.
1 plus, or no,
Something like that. 2 tangents x over 1 minus tangent square x. Okay, let us solve a problem, and then we're gonna go through the other kind of identity and then do some proofs. Okay, we're gonna skip this first part because we did just prove it. Let's do the second one. Solve algebraically in the unit circle. Sine 2x equals cosine x. Okay, let me talk about some strategy in solving this kind of problem. First of all, you cannot solve this when one of them, the variable is 2x, and the other one is x. If they're not the same, then you need to make them the same. So how do we make sine 2x so that it's no longer 2x and just x? Oh, cannot go inside a sign. Change it to what?
the 2 sine x
2
cosine.
sine x cosine x. Okay, now we can solve because they're all x's. Okay, if one of them is a 2x or 3x or 4x, you cannot solve. Okay, now that they're all x's, we can solve. What do we do if we want to solve an equation? Make one side equal to 0. So 2 sine x cosine x minus cosine x equal to 0. Okay, solve. Let me know when you're done. All right, so take out cosine. 2 sine x minus 1 equal to 0. So cosine is equal to 0, or 2 sine x minus 1 is 0. So that means sine x is equal to 1/2. So x is equal to 90 degrees to 70 degrees. And then for sine equal 1/2, it's 30 degrees and 150 degrees. They are not asking for all solutions, so that's it. Okay? All right. Let's solve a problem from your homework. That is very hard. So let's do that on the side. I think 28. Cosine 2x plus cosine 4x equals 0. Can we solve it as is?
No.
No, why not?
Because the number is different.
The number is different, 2x and 4x. So what can we do? We need to make them the same.
You can change cosine to
Change.
and cosine.
Okay, so change them both to what?
2x plus
2x, 2x, or 4x?
What?
2. So 2x and 4x, we need to change them, right? So that they're the same. So do you want to change them to x, 2x, or 4x? Which kind?
X.
X?
Yeah.
Okay. All right. We can do x. X is not the easiest way.
Then what's the easiest way?
To,
2x.
yes, get them to 2x. That way you have one less step. All right, so how do we change this cosine 4x into a 2x?
2x plus 2x.
No, that's not the correct formula. Cosine 2x, okay? What's another way? So someone says cosine 4x is the same as cosine 2 times 2x, right? So double angle formula. What's another way?
2x
One
plus
is
2x.
1 plus 4?
1 times 4.
2x plus 2x.
1 times 4. Okay, 2x plus 2x. Okay, the two methods are going to be different. This one is going to be double angle. This one is going to be sum and difference. You'll still get the same answer. It's just that your approach is, I'm not sure. I think both of them are going to be the same. All right, pick one. What do you guys want to do?
Double sum.
Double. No, already knows right now.
Okay, double angle. Double angle for cosine has 3 options. Which option do you guys want to do?
Easiest one.
Ooh, let's think about our question. On the left-hand side, or this part, is a cosine 2x. So which one should we?
Cosine squared x minus 1.
Okay, all right, so 2 people are really, really fast. Let's think about it. We have 3 options. To solve this problem, remember that one of the term was a cosine 2x. You want to solve it, so that means you need to try to get all of them to be a cosine or to get them to be a sine. Since that part is unchangeable, the cosine 2x is unchangeable, which one of these 3 would be easiest for you to solve? Second one, because the second one has a cosine, right? And no sine. Does that make sense? So you want to pick and choose. There's always one that's a little easier than the other. Okay, so 2 cosine squared minus 1 would be the easiest. Let's apply. Okay, cosine 2x is the same plus double angle formula. Well, what was it? I don't remember. Was 1 minus 2 cosine squared? No. 2 cosine squared.
X minus 1.
2 cosine squared x minus 1. Okay, so 2 cosine squared x. Is it x? 2x. Because our variable is 2x now. Does that part make sense?
Yes.
Oh, this is the only one answering. Okay, people who are thinking it doesn't make sense are not talking. Okay, so this is the application of this one here. This becomes 2 cosine squared 2x minus 1 because the variable here is 2x. Are you guys okay?
Yes.
Okay, moving on. Now we have this, I'm going to put this in order of the degrees. Okay, talk to your partner. What should be the next step in order to solve this problem? Talk to your partner. Okay, what's the next logical step to solving this problem? Factoring. So this time when we factor, it's going to have a 2x, but that's okay. 2 cosine 2x, and then cosine 2x. Okay, what should be the numbers at the end? Okay, so I'm factoring, thinking that my variable is cosine 2x.
Oh, okay.
Okay, so what should be my factors?
Minus 1.
Minus 1 plus 1. Okay, that's equal to 0. Okay, so 2 cosine 2x minus 1 is 0, or cosine 2x plus 1 is 0. Solving, cosine 2x is 1/2. Cosine 2x is minus 1. Okay, you and your partner are going to solve this, just like what we did when I showed you before with the 2x. Be careful, you are going to add the 360n and then divide by 2. Okay, go ahead and figure out the answer. All right, let's take a look. Cosine 2x equals 1/2. What angle gives cosine a 1/2?
90. Or not 90, sorry, 60.
60 and 300. Now, the answer is only within the unit circle, but we do have to add 360 and to begin with because we may miss some angles if we don't. Okay, so now what we're going to do is divide by 2. So that means the angle is 30 plus 180n. So choosing the angles that's only within the unit circle, that gives us 30 degrees, and then 180 more of that is 210. And then if I add another 180, I'm going to go over the unit circle, so it's just 30 and 210. If you only had 60 to begin with and then just divide by 2, you would never find the 210. Does that make sense? No.
How'd you get
Okay, so this cosine 2x equals 1/2 means try to find an angle that makes cosine 1/2, which is 60 or 300. But that is equal to 2x. So we had to find x. So technically, we just divide by 2.
Did you do the bottom one yet or no?
Not yet. Okay, so you divide by 2, which gets you 30. However, there is another angle that will also work. Bless you. Meaning there's another angle when you double it and take the cosine of it, it will get 1/2. And what is that angle? That is 210. Oh no. I am not making a lot of sense. Yes. Oh, okay. Today's not my day. Okay, give me a thumbs up if you got it. Like I can do this without a lot of help. Sideways thumb, I'm kind of confused, but I think I'm okay. Downwards thumb, I don't know what's going on at all. Okay, all right. Okay, let me think about how to explain this. Let's try this one. This may be an easier angle to explain.
Wait, you don't have to get the bottom one?
We do. Okay, divide by 2. 150 plus 180n equals x, so that is 150 or 330. Okay, so let's talk about this one. Okay, so hopefully this will be easier to explain what the concept is. Cosine of some angle is going to give you -1. What's that angle?
90.
180. So 2x is equal to 180. Right? X is equal to 90. But that's not true. There is another angle. So what you're doing is you're thinking what angle doubled. And then when I put into cosine will give me -1. What angle doubled? Okay, what angle doubled put into cosine will give me -1?
45.
1/2.
Angle.
130.
Why is it so hard to explain? Huh?
315.
Oh.
360.
Okay.
540. Well, plus the.
Okay.
Yeah.
Cosine. Cosine equal -1, that is right here. This angle is 2x. So x is 90, right? Obviously. But there is another angle that's going to give me
What?
270.
Doubled, it's,
Yeah, if it's
which is.
doubled, so if you are at 270, if you double it,
Oh.
you will be here, right?
Oh. Yeah.
Yeah.
What's it mean?
Okay.
So you just find it or?
Okay, I'm gonna just tell you how to do it. If you are very interested in why it works, then you can come back later. Okay.
I have a question.
Oh, you have a lot of questions. Hold on. Let me finish explaining. Okay. The general process is when you have this whole thing, cosine 2x equals -1, or whatever the answer is, you take that angle and you ask yourself what angle would give cosine blah. Okay? And then you have 2x equal 180 or whatever it is. Make sure you add 360n.
That was my question.
Okay, yeah. If you add 360n, you will cover everything. If you don't add 360n, you may miss some angles. Now you divide everything by 2. So now the answer is 90 plus 180n.
Oh, so it became 270.
Yes, and then so you ask yourself, oh, okay, well, first one is 90. The second one is add 180 to it, which is 270. So both of them, when you double it, put it back in cosine, you will get -1. Sunny's already sleeping. Okay, all right, we gotta move on. We gotta move on, and we are no time.
1 minute.
Okay, let's talk about the half angle identity. So first, sine x over 2 is equal to plus minus square root of 1 minus cosine x over 2. And cosine is similar. It's cosine x over 2 is equal to plus minus square root of 1 plus cosine over 2. Now, it's not using plus minus in your answer. You're actually going to choose plus or minus depending on where the angle is. And I'll show you that later. For tangent, there are 3 different choices, but the basic one is tangent is just sine over cosine. So if you take the sine formula divided by the cosine formula, you are going to end up with plus minus square root of 1 minus cosine x over 1 plus cosine x. Now the second formula is very simple. What you want to do is just rationalize the denominator. So looking at this, if you rationalize the denominator, so kind of think about it. This denominator will become 1 plus cosine x. The numerator is going to be 1 minus cosine square x, but inside the square root. The denominator comes out because you're multiplying the same thing to the same thing, so the square root goes away. In the numerator, it is not the same thing. 1 minus cosine times 1 plus cosine is 1 minus cosine squared. Now notice that 1 minus cosine squared is really just sine squared. So then square root of sine squared really is just sine. So this is the second formula when we rationalize the denominator. The third one, we're going to do the same thing, except we're going to rationalize the numerator. So 1 minus cosine on top and bottom. Okay, so this is the third one. Notice that in the top, in the numerator, we're multiplying the same thing to the same thing, so that is going to be a 1 minus cosine. In the denominator, again, we're going to have a 1 minus cosine squared. And again, that 1 minus cosine squared becomes sine squared x, where square root of sine squared x is just sine. So that is my third one. So again, when you get to tangent, you're going to pick and choose which one you want to use. Okay, let's solve a problem together. Let's look at sine 15. So sine 15, we did that last section where we did a sum and difference formula. This time we're going to use half angle identity. Half angle means we're trying to figure out what angle divided by 2 will give me 15. That is going to be 30 degrees. Okay, so plus minus square root of 1 minus cosine of what? That is going to be cosine of 30 because that is the angle we're dealing with, the x. Okay, now evaluate. Cosine 30, think about where cosine 30 is. Cosine 30 is square root 3 over 2, and this whole thing is over 2. Now, remember algebra 2 where we simplify complex fraction. Okay, first we need common denominator. So plus minus 2 minus square root 3 over 2 over 2. Okay, simplify this some more. Plus minus square root of 2 minus square root 3 over 4. Okay, the denominators multiply together. Okay, square root of the top is just nothing, so we leave it as is. 2 minus square root 3. In the denominator is just a 2. Now the last step is figuring out whether we're going to use plus or minus. So you ask yourself, this is asking for sine 15 degrees. Where is 15 degrees? 15 degrees is in first quadrant. So sine 15 degrees, sine at 15 degrees is going to be positive. So we are going to only use the positive for the answer. All right, let's look at the next one. Solve. Sine square x is equal to 2 sine square x over 2. Okay, sine square x over 2 is the same as sine x over 2 squared. Now, sine x over 2 is really just a half angle identity, so we are going to just change it, because notice that we talked about this before. If you have two different variables, you cannot solve. You have to change both of them into the same thing. Whether you want that to both be x or x over 2, doesn't matter. I don't know anything that changes from x to x over 2, so we're going to just do this half angle formula. Okay, so this is going to be plus minus square root of 1 minus cosine x over 2, everything squared, because this half angle formula is just this one. All right, so this is going to be sine square x is equal to 2 times 1 minus cosine x over 2. Notice that the plus minus is gone, but because when you square something, it always turns out to be positive, so there is no plus minus. And that square root sign is gone because when you square something, square root sign is gone. 2's cancel. Sine squared x is equal to 1 minus cosine x. Okay, again, when you solve something, you want to make it equal to 0. Sine squared x minus 1 plus cosine x is equal to 0. Again, this is a point where we cannot solve because we have sine and cosine in the same equation, and it's not in factor form, so we cannot solve. So what we want to do is either change everything to sine or everything to cosine. In this case, it's much easier to change everything to cosine. So sine squared is 1 minus cosine squared, minus 1 plus cosine is equal to 0. So the 1's cancel. We get minus cosine squared x plus cosine x is equal to 0. Okay, so this becomes, take out cosine, so cosine x, and then negative cosine x plus 1 equals to 0. So cosine is equal to 0, or 1 is equal to cosine x. So that gives me x equals to 90 degrees, 270 degrees, and then cosine x equals to 1 at 0 degrees. It doesn't say that it wants all angles. I am going to just leave it like that. Now let's look at this next one. Prove the identity sine 4x is equal to sine 2x and cosine 2x. Notice here it's a 4x. These are 2x's, so somehow we have to change the 4x into 2. Think about how you're going to do that. Well, to get from 4 to 2, we know that we are going to probably do a double angle formula. So we can think of sine 4x as 2 times 2x. And looking on the right-hand side, 2 sine cosine, that reminds me of double angle for sine. And we are basically done. So 2x is kind of the variable. So we can think of this as sine 2 times something, which is going to be the identity 2 sine something, cosine something. This is the double angle formula for sine. Okay, so now substituting in 2x into all the boxes. This is in fact 2 sine 2x cosine 2x, and we are done. Okay, the power reducing identity. This is used when you want to change from a higher degree to a lower degree. For example, if you see something like this, sine squared x, and you want to reduce it so that the power is not second power, you want to reduce it to a first degree, you can use this identity, 1 minus cosine 2x over 2. Notice that this cosine is just first degree. Of course, you gain a 2x instead of a second degree, but sometimes it's helpful to change it like this. Cosine square x is the same. It is 1 plus cosine 2x over 2. And then the tangent square x is going to be 1 minus cosine 2x over 1 plus cosine 2x. Okay, the power reducing identities we don't use very often, but in proofs we will see that sometimes. Just know that they are there, and you may need to use it if there is something you cannot prove. Okay, so let's take a look at a problem. Let's try this one. Okay, rewrite cosine to the fourth x in terms of geometric functions with no power greater than 1. Okay, it is not sufficient to just write it as cosine x, cosine x, cosine x, and cosine x 4 times. They do want you to change it so that you cannot multiply it back together and get a power higher than 1. Okay, we have no choice but to use the power reducing identity. Power reducing identities are all in terms of squares. This is to the fourth, so how do we change a fourth degree into something that has a second degree? What we can do is change fourth degree into second degree squared. Okay, that's going to give me 4 degrees. Okay, now we use the power reducing identity. Cosine squared x, we just did that. It is 1 plus cosine 2x over 2 squared. Okay, let's FOIL that. 1 plus cosine 2x squared, we get 1 plus 2 cosine 2x plus cosine squared 2x. Okay, square the first term, square the last term, take the product and double, and this is all over 4. I don't really like fractions, so I'm going to put the fraction in the front. 1/4 times 1 plus 2 cosine 2x plus cosine squared 2x. At this time, you notice that this is still a square. It is still a power greater than 1. We need to reduce it again, so we had to do a power reducing identity again. Do that here. 1/4 times 1 plus 2 cosine 2x plus. Okay, we're going to do a power reducing identity. Remember, power reducing identity is 1 plus 2 times whatever that is divided by 2. Now that whatever that is in this time is 2x. Okay, so then applying that formula, it's going to be 1 plus cosine 2 times whatever that is. The whatever that is 2x this time over 2. And we are not squaring anything. Okay, so that's that. 1/4 times 1 plus 2 cosine 2x plus, okay, 1 plus cosine 4x over 2. All right, pretty much we are done, but let's try to simplify this some more. Okay, I can see that this part is a fraction. This is not a fraction. There's a constant in the front. It is a little awkward. So what we want to do is make sure that they all have the same denominator. Okay, so what should we do? Okay, I'm going to multiply everything through so that they all become fractions. 1/4 plus 1/4 times 2, that is cosine 2x over 2, plus this 1/4 times the 1/2 here becomes 1/8, plus the 1/4 times the cosine 4x over 2, that becomes cosine 4x over 8. All right, now they're all fractions. I need to make sure that they have common denominator, which is going to be 8. So this becomes 2 over 8. This becomes 4 cosine 2x over 8 plus 1/8 plus cosine 4x over 8. All right, combining all things together. 3 plus 4 cosine 2x plus cosine 4x over 8. And the last thing we can do is just pull that 1/8 in the front. 3 plus 4 cosine 2x plus cosine 4x. And we are done. Now, no powers are greater than 1. I know there's a lot of algebra in this. It is doable. It's just a little long.